Welcome to Crystal Clear Education Center. Here, a learning made simple. In our last video, we saw about various formula from electricity lesson. Now, we are going to see the derivation of the same formula from Ohm's law to the electric power in a very simple manner. So grab it and learn it. Before going into the class, let us see today's code. Do not allow people to dim your shine because they are blinded. Tell them to put some sunglasses on. So let us stay positive always. Today's topic is electricity, class 10, and we are going to deal with derivation. As I said, from Ohm's law to electric power. So start along with me and take the notes. Here we are. Ohm's law, number one, will start from Ohm's law. Ohm's law is nothing but a proportionality between two physical quantity. One is potential difference, another one current. And by this symbol, you can guess very easily, it is directly proportional. Potential difference is directly proportional to current. How will you say in a statement? Just this figure you keep in mind, this A, B wire and temperature, these two words, along with this you keep in mind. Now see how I'm going to define. Potential difference, V is potential difference, right? Potential difference across the 2 points of a metallic conductor. Just why that's what I've written A and B. 2 points of the metallic conductor is directly proportional to the current through the circuit, provided the temperature remains constant. That's it, right? And V is equal to Ri, we all know. So what is R? To remove the proportionality, we are introducing a constant called resistance, right? And this resistance and I, how they are related? Always they are inversely proportional. Okay, current is inversely proportional to the resistance. And you can see here the VI graph where you can see a linear line called the resistance. The same thing, suppose if I'm going to draw a line like this, and if I'm going to draw a line like this, and in exam, you are going to get a question like this stating A, B, and C, which is having the high resistance. The question is, which has high resistance? Answer. What I'm going to do to simplify this, I'm going to keep a dotted line. Just see here. You can also do it in a rough way. So this is the point, another point is here. And now if you see the current value, suppose if I'm going to give the value 2, 4, 6, like this, I'm going to give a value in current in ampere, I'm going to give. Now this part for A, if you see the current value is low. The other thing, it is more. And we all know current is inversely proportional to resistance. So if the current value is low, naturally the resistance is more. So A has the high resistance. Okay, because the current is low, only 2 ampere current. The other thing, if you see 4 and 6, got it? This is a very important 1 mark question or 2 mark question also. Next, we'll move into the unit of resistance. So resistance SI unit is ohm. Okay, this is a symbol which you call it as omega. Okay, 1 omega or 1 ohm is equal to 1 volt by 1 ampere. Okay, which is nothing but when potential difference of 1 volt and current through the circuit is 1 ampere, then the resistance is 1 ohm. Okay, this is another important question. Define 1 ohm or define the SI unit of resistance. You have to define the SI unit of resistance. Don't write SI unit of resistance is ohm. That is wrong. When they are asking define, I'll double underline, define the SI unit of resistance. All right. Now, next quantity is resistivity. Before going to the resistivity, in last video, I told about LANT. Okay, the factors affecting resistance, LANT, right? So let me erase this and I will tell you the resistivity. Okay, I'll erase this side so that the resistivity you can copy it. So what is resistivity? Again, I'm going to relate the resistance with length and area. So R is directly proportional to length. Whenever the length of the wire increases, the resistance will also increase. And that is why R is directly proportional to L. This is R is equal to L. Okay, 2R is equal to twice the length. Twice the length, twice the resistance. Okay, like that it doubles, right? Whereas R is inversely proportional to the area. Okay, so if the area is reduced, the resistance will increase. If the area of cross section actually it is, right? You can see the area of cross section. If the area is more, the resistance is less. If the area is less, the resistance is more. And that is why it is inversely proportional, right? So when we are going to denote it, R is proportional, directly proportional to the length and the area. We can use small letter itself for L, the length, right? So L. And now to remove the proportionality, I'm going to introduce a constant rho, 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 and it is like a small p, the symbol. Okay, R is equal to rho L by A. Okay, so it is defined. Okay, the resistivity is defined as the resistance offered by a cube of material of side 1 meter when current flows perpendicular to its opposite faces. And that is the definition of resistivity. And the SI unit of resistivity is ohm meter. Okay, this is another important question, right? We'll move on to the next topic, resistance in series and parallel. Okay, you can see the circuit diagram here. And here, if you see, what is series, what is parallel actually? Anything, okay, which is going in order, like one after the other. Okay, this you call it a series. Okay, whereas it breaks and go. For example, a water. Okay, I'm going to send water through a pipe like this. Okay, and that pipe, it is going to divide like this. Okay, and you can see the water will be flowing both the side. Okay, we can make it as AB, the subdivision of the pipe. Okay, this is pipe. In the pipe, the water is flowing, and what happened? There is a division in the pipe. The pipe is divided into A and B, and the water is flowing through A and B as well, right? In a two different way, right? Suppose if the amount of water is something 100 gram or some, I mean, I can take it in a volume or mass, whatever it is. You see, it is divided here. Similarly, in circuit, okay, if you see here, the current is flowing. Okay, imagine the same water. The current is flowing, and the flow, if you see, it is divided. It is divided into three. So the current is divided into I1, I2, I3 for resistance in parallel. Okay, for resistance in series, if you take, the current remains the same because there is no division. The current is same in all the three. Okay, whereas here the current is divided into 1, 2, and 3. This is a very important difference between these two. And next, if you see the voltage, okay, the voltage is different in this three resistor, V1, V2, V3. Here, if you see, the voltage is same. Can you see this? The voltage is same, right? For all the three resistor, we can name it as R1, R2, R3. For all the three resistor, the voltage is same. Whereas the resistor, each resistor will have different voltage, but the current is same. So I'll write as I same, which is current, voltage different. Okay. Whereas here, what is I? The current is different. Okay. Whereas voltage is same. Okay. For resistor in parallel. And this is resistor in series, right? So now we'll go into the derivation. Hope the concept is clear here. With Ohm's law, with the help of Ohm's law, we are going to derive resistor in series and resistor in parallel. The resistance in series, how it will be? If the resistors are connected in series, you can see the series. As I said, the voltage. Okay, let me use this color. Yeah. As I said, V voltage is equal to V1 plus V2 plus V3 because three different resistor will have three different voltage, right? And now we know the formula V is equal to IR. Okay, but it is V1 R1. V2 is equal to IR2. V3 is equal to IR3, right? And now I'm going to substitute this one in this, right? So we all know the general formula V is equal to IR. In the place of V, I'm going to substitute the IR. So IR is equal to V1 IR1 plus V2 IR2 plus V3 IR3. Okay, instead of V1, I'm going to use this. Instead of V2, I'm going to use this. Instead of V3, I'm using this. Now, IR is equal to I'm going to take it common. R1 plus R2 plus R3. Now this I cancel. So resistor in series, yes, is equal to this one. So let me write here resistor in series. RS is equal to R1 plus R2 plus R3. Okay. Now come this side. I in resistor in parallel, I is divided. Current is divided into I1, I2 and I3. All this put together only I current. Now the same thing I'm going to use in VIR. Instead of this, I will use directly I is equal to V by R. So I is equal to V by R. Okay, how we are getting I is equal to V by R? Since V equal to IR, IR equal to V, R equal to, sorry, I equal to V by R. Okay. I equal to V by R. Okay, have this one also. From this only I'm deriving and I'm getting this one, right? So I1 is equal to V common R1. I2 is equal to V common R2. I3 is equal to V common R3. Now add together, use this one instead of this. Okay, this if you want, you can make it as equation 1 and you can substitute, or directly we can use. Okay. You can use it as 1. Here also you can use it as 1. So apply it in equation 1, you can write it. So I'll write here I, instead of I, I'm going to use 1 minute. Yeah, I'll use this side with another color. Okay. Yeah. So instead of I, I'm going to use V by R is equal to V by R1 plus V by R2 plus V by R3. So I can use it as V into 1 by R is equal to all the V, let me take it common, 1 by R1 plus 1 by R2 plus 1 by R3. And this V we can cancel. 1 by R resistor in parallel is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Got it? So the same thing we got, R S is equal to R1 plus R2 plus R3, right? This is star in series. Okay, next we'll move on to a very interesting concept, heating effect. Okay, as well as we'll move on to the power. So first we'll talk about heating effect. Heating effect of current. With a core formula, we are going to use the very important formula for this is potential difference. V is equal to W by Q. Okay, potential difference is nothing but the work done to move the charge from one point to another point. So this is only the important formula. And now I can write W is equal to V into Q also, I can write it. And we all know when the work is done, heat is generated. So W is equal to H. Now, instead of Q, from the current formula, we know I, current, is equal to the rate of flow of charge. The same thing I can write Q is equal to IT. So apply this one. Since I is equal to Q by T, I'm using V into I into T, which is nothing but VIT. Okay. Now, from Ohm's law, we all know V is equal to IR, right? From Ohm's law. So apply that. Apply Ohm's law to remove V. So we get H is equal to IR into IT. There is nothing but I square RT. Okay, heating effect. So all the three are directly proportional. If you see, if you want to relate the proportionality, H is directly proportional to current, okay, or the square of the current, and H is directly proportional to the resistance, and H is directly proportional to the time. All the three are directly proportional. And now next we are going to talk about the power, electric power. Okay. Electric power, the normal power formula we know, power is equal to work done by time taken. So power is equal to work done by time taken. So we know the work done, okay, since W is equal to V into Q. Okay, so we'll apply P is equal to VQ by T. And we know Q is equal to IT. So V into I into T, okay, by T. And this T will cancel. P is equal to VI. This is one. And we are going to relate it with the Ohm's law. And we are going to derive the other one. So check that one with Ohm's law. The same thing. P is equal to VI. I'm going to apply Ohm's law. That is V is equal to IR. So instead of V, if I'm going to use this one, it will become P is equal to I square R. Okay. Then number 2, same, P is equal to VI. Again, I'm going to apply Ohm's law. And I'm going to use in now I is equal to V by R. Now check, instead of I, I'm going to use V by R. So P is equal to V into V by R. That is nothing but P is equal to V square by R. So electric power, if you take, it has 3 formulae, 1, 2, and 3. Power in relation with potential difference and current. Power in relation with current and resistance. power in relation with potential difference and resistance. So keep practicing this derivation. It will be really helpful for you, your board exam. Let me meet you with another video where totally we are going to solve the numericals. Thank you.